Hello, Precalculus student. This video is for chapter 6.3, Inverse Trig Function, part 2. So in the last video, we were looking at find the exact value of some inverse trig functions of special angles values, or value corresponds to special trig functions. So we know the tangent of something, there is an angle tangent that would be equal to negative root 3, right? So, but we cannot look it up in the unit circle. So what should we do? In the unit circle, we only have sine and cosine. So sine and cosine are easy to do. But in for tangent, we know that it's from quadrant 1 and 4. And this is a positive angle. This is negative angle, right? But the value doesn't show up. So we have to actually kind of figure out a way to record the tangent function so we know what value they corresponds to. So what we can see is if we have tangent is described as sine over cosine, so we can actually pre-do some of the values. So for 30 degree, we know it is 1/2 over root 3. So this is root 3 over 3 positive. This is 1. And this is root 3 over 1. So that's root 3. And here is 1 over 0 is 0. That's undefined. We don't use it. So we have root 3, 1, root 3 over 3. And also we have, again, negative root 3 over 3. So because 1 over root 3 is negative root 3 over 3, negative 1 and root 3. So you need to have these written in your, in your unit circle so you can do the reverse lookup for tangent. Now, in the last question that we were working on, we need negative root 3. Where is it in the unit circle? Negative root 3 is, this is negative actually. So these are all positive. This is negative. It's actually this angle. This angle is actually negative pi over 3, right? So we say this is negative pi over 4. All these angles, you don't use the original positive angle, but you name them as negative pi over 6. So negative pi over 3 is the input is negative pi over. For negative root 3, the input was, for tangent is negative pi over 3 for this restricted domain. So we say the answer is negative pi over 3. Okay, not 5 pi over 3, not 4 pi over 3, but negative pi over 3. That's how the mathematician has chosen, because for tangent we choose from negative pi over 2 to pi over 2. So what about arctangent with 3 over 3? So tangent of what? So if this is the angle that would give, if I do the tangent of this angle, it should give an angle of 3 over 3. So in the unit circle, the tangent unit circle, we have 3 over 3 right here. So that corresponds to the positive angle of pi over 6, right? So you can you still do reverse. You do look at the unit circle, but reverse lookup, that's pi over 6. So the idea is inverse function would be, you think of sine of what equal to this. So when you look at the unit circle, you do reverse lookup. And of course, there are a lot of value that does not correspond to the special angle. So we would need to use the calculator to do it. So the calculator, we for cosine, inverse cosine, inverse sine, and inverse tangent. This is a typo. Inverse tangent are available, but cotangent, secant, and also cosecant, inverse, these are not available most of the time in a calculator. So to do those, you find the same angle by using cosine inverse 1 over the value. Because if you have an angle equal to this, equal to an angle, right? So it must be that secant theta equal to x, right? That is the meaning of a secant. So, but secant is the inverse of cosine. And then if you switch it over, that means cosine equal to 1 over x. Cosine equal to 1 over x, that means secant inverse, cosine inverse 1 over x would equal to the same angle. Okay. So you do the inverse inside if it is a scientific calculator. But if you use decimal, actually, I think they have the function. So let me make sure that this is, oh, no, let me make sure that it is in radian. You also need to make sure that it's in radian. Why? So we say cosine, no, secant inverse. Can we do that? Would it work? Inverse 1 over, no, 1.3. Yeah, I think you can just do secant inverse. So if you use decimal, you don't have to do those things. And you can check if I do cosine inverse, but 1 over, see, 1 over 1.33, it should get the same angle, right? So if you have a calculator that doesn't have the secant function, but the cosine inverse function, that's what you do. Okay. Let's go back to the notes. So use a calculator to do. I'm going to use a graphing calculator. So I have a graphing calculator that I can use. So some of you have graphing calculator, we can use this. So these, the sine inverse, cosine inverse, and tangent inverse are right here. So you use the second command to do it. Okay. Okay, so the first is arctangent negative 4.12, and we wanted to the output to be degree. So negative 4.12 in degree. So first of all, I have to change into degree. Right now, yeah, it is already in degree, right? So this is already in degree. So and then we quit, and then arctangent negative 4.12. So it's negative 76.3570. Negative 76.3 what? 3570 degree. What about sine inverse 0.2367? So we would do sine inverse, this one, 0.23, what was it, 67? 13.6919 is equal to 13.6919. Remember, this is a degree. Arc cosine, it's in the calculator. 0.3. 0.3. 72.5424. 72.5424 degree. Cosecant. So this is the one that is not in here. So cosecant is the inverse of sine. So I would do arcsine, but I would do 1 over that value. What was it? 2. So I would just do 1/2. Oh, sorry. Didn't finish it. Sine inverse 1 over 2. 30 degree, right? So that's pi over 6, 30 degree. Okay, so find the approximate rate in radian. So, okay, remember we're doing radian now. Switch it back to radian. Okay, radian. Exit. And arctangent 1.88. So we have that. Arctangent 1.88. It should be a positive radian angle. 1.0819. 1.0819. Cosine inverse 0.76. Cosine inverse 0.76. 0.7075. 0.7075. These are all radian angles. Arcsine 0.23. Arcsine is this one. 0.23. 0.2321. Arcsecond, so this is not here, so but arcsecond is the inverse. The inverse of secant is cosine, so 1 over, what was it, 1.44? 1 point, point 44. 0.8031. 0.8031. And arc cotangent, negative 0.82. So we do the cotangent, 1 over 1, over negative 0.82, negative 0.82, negative 0.8840, 8840. Yeah. So that's how you do them in a calculator. And in decimal, you don't have to do the 1 over because they have all 6 inverse trig function. Okay, so what is the application of the inverse trig function? It can be used to find an angle if you know the ratio. Okay, so if I have, say for example, I have a triangle, right triangle, SOHCAHTOA, theta is here, x is on this side, and 4. So how can I actually say theta equal? Theta equal what? So I can just do the tangent ratio because it's value is tangent because it's opposite and adjacent, right? TOA, opposite adjacent. So tangent of theta equal to x over 4. So theta would be equal to arctangent x over 4. So that's how you can solve for theta if it is an unknown. So right angle theta in terms of h and p. So h and p. So h and p this is hypotenuse and that's opposite, right? Opposite hypotenuse is saw. So we say sine theta was p over h. What is theta then? Theta would be sine inverse p over h. Okay, so this is a formula that you can use in case, yeah, and then you can use the sine inverse to solve them. Okay, so we are actually solving the angle now. So in degree, okay, find angle in degree if I have two sides, 12 and 9 in a right triangle. So this angle and two sides are related by saw. Oh, no, this is adjacent and this is O. This is hypotenuse, not O. Adjacent and a hypotenuse, so this ka, right? Ka. It's not saw, it's not TOA. So cosine of this theta is equal to 9 over 12. Okay, theta would be cosine inverse 9 over 12. 9 over 12 is not a special angle, so we use the calculator. I'm going to use my handheld calculator, so it's cosine inverse 9 over 12. 41 point. Is it in degree mode? Yeah. Okay, it has to be in degree mode. Okay, 41.4. 0.4096 degree. Okay. Do the 2 here. So this is opposite and hypotenuse, right? So sine of the theta equal to 14 over 24. So theta is sine inverse 14 over 24. Sine inverse 14 over 24. That is 35.6853. And for this one is tangent. Tangent theta equal to 8 over 20. So theta equal to arctangent 8 over 20. Why is it tangent? Because it's opposite of a hypotenuse. So 8 over 20, 21.8. So theta is 21.8 degree. Okay, so this is also degree. So it is a very useful way to find angles. a given length.